So this is all about creating geoprocessing tools in a Python toolbox. So part of 10.1 is the Python toolbox. So if anyone out there right now, unless you've had a chance to work with a pre-release or a beta cut of 10.1. Has anyone been in 10.1 beta or pre-release? Had a chance to look at a Python toolbox yet? Okay. Well, then it's brand new. So historically, we've been able to create script tools using the script tool wizard. Python toolbox is sort of a new way of doing sort of the same thing. But before I get too far along that, who's here for the first time at Dev Summit? All right. Yeah. Yeah. Is everyone reasonably familiar with geoprocessing in general already? Yes. Okay. Python. All right. And script tools. All right. Okay. So we create tools for a number of reasons, right? But the biggest part is to make sure we can take any little bit of code that we write, whether it be a few lines or a big sophisticated program, and we can pull that in and use it within the geoprocessing framework. So when you create a script tool in the past or a Python toolbox now, you can then take that code and it becomes part of the application. You can run it from a tool dialog. You can add it to ModelBuilder. You can call that tool directly from Python. And it's a familiar thing, right? If you've used geoprocessing before, you can present someone with a new tool, even if it's your own creation, they sort of have a already intuitive understanding of how that tool works. And once we put something into a script tool or a Python toolbox, there's some basic validation that happens on that tool that you can use to sort of save yourself from doing all sorts of coding within your code. For instance, you don't have to bother checking about the data type or whether data exists. All that sort of is taken care of you by the front end of the tool. We create tools because they're easy to share. At 10.1 we have this new packaging story where you can package up a tool with data. But in the past, script tools have always been reasonably easy to share already, right? It's just a couple files. You can move them around. You put them on one machine and it should just work as it worked on any other machine. And another good thing about working with tools is that they communicate, right? They communicate inside the application. So a tool automatically understands the layers that you have in the table of contents, or you can send messages from the code back up to the application that someone on the front end of the tool, someone using that tool, can see. Now, when we talk about tools, and this is going to be sort of a common theme throughout today, is a geoprocessing tool really does three main things. Right? It defines its parameters. So when you open up a tool dialog, you see a list of parameters. That's one thing. It validates those parameters. And there's sort of two levels of validation. There's validation that data types on their own will take care of, and then there's validation that you can do as well on top of that. And then the third part of a tool is that it then executes some code underneath the covers. And that's sort of Dale's going to actually run through more of the script tool side of things, and then I'm going to take over again, and we're going to talk more about the Python toolbox. But creating a tool should be the easiest part, right? The algorithms, the little code that you want to make into the tool, that's the key part, right? Making the front end of the tool, making it work nicely and all this should be the easy part. So in a script tool wizard, this is sort of how the process went. You'd right-click in a folder or a G database and you'd create a toolbox. And then you'd go through this parameter wizard to define the parameters and sort of high-level stuff about the tool. And then you could come back to that tool. You could add validation code of your own to fine-tune how the tool operates. And then you could attach a PY. And I'm going to let Dale run through that process.
All righty. So just to reiterate here, starting at 9.3, you could always create your own script tool in a custom toolbox, and that's what we're going to do now. And what Dave is talking about is now we have this thing called a Python toolbox at 10.1. So what I want to do is just go through real briefly how you create a script tool at any version of ArcGIS. So here I have a little a map of San Francisco. I'm going to create a custom toolbox here. Notice here at 10.1 I've got this Python toolbox. Dave will be talking about that, but I'm just going to create a custom toolbox. And like any toolbox, I can go in and add a model, but I can also add a new script. And that's what I'm going to do now. The script tool wizard opens up. Now before I add this script, what this script is it just takes a table and it outputs it to an HTML file. I'm going to look at the piece of code. This is something called PyScripter. It's a freeware available. I think it's a Google thing. Let's just take a brief look at this little piece of code here. It gets a parameter, which is the name of the table. And, gets a parameter, which is the name of the table, and it gets an output file name, which is going to be the HTML file name. It opens up that output, writes some HTML stuff, loops through every field in the input table. If it's not a geometry or blob field, it is going to write it out here into a table format. And here it's opening up the search cursor, and it's going through every field. So as you see here, this script has two parameters, an input table and an output file. So going back to here, I'm going to give my script a name, table to HTML, a label, which is the thing that shows up in the user interface. It can have spaces. I can give a description. I'm just going to keep going here. I'm going to give a script file. I'm going to browse to my directory in my home folder where I keep my scripts, and the script is called table.html. Next. So what I want to do is I want to define the parameters that I want to be on the tool dialog. Remember, we have two parameters. We have the input table and the output file name. So I just click up here. I start defining my parameters input table. In this case, it's going to be a table view, which is either a table on disk or a table I created by joining other tables together in a table of contents. It's a required input, and that's about it. I have an output file, output HTML file, and it's I guess I should warn you, I know how to use this UI pretty well, so that's a file type, and it's going to be an output. And one of the things I can do with a parameter here is I can set a filter. I can say, hey, it's going to be an output, but I want the extension to be HTML, which means that I will always make sure that extension exists, and when I browse, I'll look for HTML files. I can finish here. So now I've created this table.html tool. I can double-click it, and now I got my two parameters. I got an input table, and I have an output HTML file. I can browse for that table, and I give an output file name. I'm going to go up here, and I got a scratch folder. I'm going to call it output.html, out.html, and hit OK. What did I give as an input? Did I give it the table to import? I might not have done that. I actually just realized that that's a very large file. Let's just cancel that. Let's try this again. And I want to see something here about the parameters, properties. Parameters. I said table. I want to say table view. That means I can choose something that's in the table of contents. Let's try this again. Now I get the drop-down list of things in the table of contents. I'm going to choose my highways data set. I'm going to go back to my home page, go to scratch folder, out.html, hit OK. Took a little quicker to run. And so what happens is that it opened up I can go to my results window. I'll copy the location of this. I'll go to my browser and I'll paste that in, and we'll get that file here. And here we have this is the streets feature class with all the fields on it as an HTML file. So that's a very basic script tool. I want to go ahead and add another script tool to show you some other features of how you define parameters. Here we go a little bit more. We say, hey, instead of just writing out every field on there, let's just let the user select the fields they want to have output to the HTML. So here we have three parameters, the input table, and then we have a list of file names, and then we have the file path, which is the output file. So let's define a script tool for that. Add a new script. We'll call it table to HTML2, something like that, table to HTML2, next, script file. That's the file we're just looking at. So we're going to define our parameters, input table. And again, I'll hit the tab key and I'll type in a T for table view. There we go. It's required input. Now I want some fields, and I'm going to say field like that. And that's an input. And I'm going to say multi-value, which means I want more than one. Instead of a single value, it's a multi-value. I'll hit yes. And then we have an output file. And that's a file. There we go. And just like before, I'm going to give it a file filter of HTML. Okay, so I define my 3 parameters. Oh, required output. There you go. Thank you. Filter. Try it again. HTML. And finish. So let's open this up. And I'll give it my input table. Highways. Well, I got a problem here already. Where are the fields, right? And so where are they? Well, let's just go back and fix that before we go any further. Let's look at the properties here. Go to the parameters. I got my fields tab. So a lot of the data, not a lot, but several data types within ArcGIS need to know the field, like fields. It needs to know what table you want to obtain the field from. And that's what this obtain from parameter is. It's also known as a dependency when David talks about in Python. So I pull this down, and I want to obtain it from the input table. Well, that right there is just the name of that first parameter with a underscore instead of a space. So I do that, hit OK. Let's run it again. Say input table, highways, and there I got all my fields. It obtained all the fields from the highways. So I can just choose a few of these fields, and I can give an output file, scratch, go out to HTML. Hit OK. And if we go to the browser, we refresh this file, we see we just have those fields output. Now there's something else about this properties here as well. On these fields, I can also set a filter. I can say a field filter, and I get a list of all the types of fields I want to allow the user to pick. And I don't want them to output XML or global IDs or GUIDs or rasters or blobs or geometries. So I don't have any of those on a table, so I can't really demo that. But hit OK here, and nothing really changes when I do this. But I get all this. Now I want to show one last thing here. Just so you know, anytime you choose a feature class or a table as input, whether it's anywhere, is it always only works with the selected records. So this streets database is fairly big. If I run this tool, we'll be here for a couple minutes as it chunks through writing that HTML out. But I'm just going to select these, I don't know, about 10 little roads up there. I'm going to run table.html, say take streets as input. I'll just take the address ranges. I want to output those. Output file. Hit OK. Ran very quickly. And if we look at the output, yea, verily, it's only those things I selected. So anytime that you're choosing something from the table of contents, a layer or a table view, anything that supports a selection, your cursor inside your script is, whoa, what happened? The cursor inside the script is what's is only going to see those selected records. So that was okay. That's about it. So there we go. So that's kind of that's the basics of adding a script tool to a toolbox. It's a 3-part thing. You first write your Python script. Your Python script receives some parameters. You go through the process of going through that wizard to say where the script resides. That's the executable. And by the way, that doesn't have to be a Python script. That can be an exe file. It can be a bat file. It can be anything that accepts parameters from standard input. We went through that wizard. We got the parameters using the ArcPy GetParameter As Text. Then we defined, through the wizard, we defined the parameters. You saw me define 2 tools, one with 2 parameters, one with 3 parameters. Parameters have a label, they have a data type, direction, input, output, derived. We'll talk about derived in a minute. whether it's required versus optional. I just did required parameters. We can set filters up on them. We can do a lot of stuff right in that wizard that defines what the parameters are and how they react. One of the things we did was I showed how you use that obtain from thing to obtain the list of fields from an input table. One of the things I did, I guess I really didn't show it here, and I'll come back to it, is that I said I want a multi-value of fields. I could have just said multi-value equals no, in which case you pass in a single field. But for that tool, I said I wanted to pass in a list of fields. And when I receive a list of something, fields like this, when I get parameter as text, it returns to me a semicolon delimited string. So let me escape out of this. I'll show you what I did in Python here. Right here, I got the field names. Get parameter as text, get me the second parameter. Get parameter text is 0 based, so the first parameter is 0, the second parameter is 1. And I use this Python directive here called split. And I give it the delimiter, which in this case is a semicolon. So what happens is that field names is actually a list, a Python list of field names. And you see down here, I actually, for field name in the list of field names here, I get the value and I write it out. And that was all part of that multi-value, handling a multi-value. We looked at filters. Oops, let me bring this back up. We looked at filters. We had a filter for a file, HTML file. I had a filter for the types of fields. For strings, you can set a predefined list of values. You can say for numbers and doubles, you can give a range of values from 0 to 10. Feature class, if you're browsing for a feature class or feature label, you can say, look, I only want to be points or multi-points or lines or whatever. So that's the basics of a script tool. And I guess before I get too much further, I want you to understand that everything that I'm showing today and everything I'm doing is in the documentation. I'm showing the 10.1 documentation here. There's a book called Creating Tools under Geoprocessing. And under here, there's a book called You Can Create Tools with ModelBuilder. I gave that session yesterday. And you can create tools with Python. And down here, here's the whole book on how we're creating script tools into custom toolboxes, which is what I'm doing today. So it talks all about how you can set script tool parameters, as I've done here. It shows the Python, the script tool wizard, what all the different choices mean. And basically everything I've done here is described in that documentation. So the next piece of it, which Dave is also going to show in a Python toolbox and talk a little bit about, is that, okay, we've used the script tool wizard to set up the parameters we want, the executable we want. But a big part of a tool is validation. And what is validation? Validation is everything that happens before you push the OK button. And the reason we have this, we talk about validation lots for two things. One is just for better user experience. Check the validity of the inputs before the tool is executed. If I type in a field name that doesn't exist, I get that big red X goes, this field doesn't exist. If my output exists, I get that little yellow message box saying that that output exists. The other reason we do validation is describe the output of the tool before we run the tool. This is so we can chain things in ModelBuilder. We do that with something called a schema. So I want to demo both of those things, get both those concepts across. When we talk about validation as well, we typically talk about internal validation or validate what you get for free just by having define a script tool. What you get for free without doing anything is that all the required parameters are there. You can't hit OK until you've filled in all the required parameters. Or all the parameters of an appropriate data type. If somebody typed in the name of a line feature class and you want a point feature class, you would get a big red X. Does the inputs or output exist? If the output exists, can you override it? Whatever. Do values match their filter? In this case, you might have a choice list of filters, and I'll show that later on. And did the user type in or use a proper string? And if it doesn't match that list, you get an error. But what we can get with full validation, that's stuff that you program, is you get things like dynamic choice list. I'll show examples of this, but here we have a hypothetical script tool. We have a file format, and if you choose new format, this feature type and file parameter, we have some new things appended to it. Now, again, I'll show that. That's a dynamic choice list. You can do things like calculate default values. Down here, the last parameter is a cell size. Based on the extent of the input features, I can calculate a default cell size. That's something I can do with my own custom validation. Other things I can do with validation, I can put things in categories. Perhaps you've seen these category windows in a tool dialog. You can custom error messages. And you can do enable and disable parameters. So depending on what they put in one parameter, another parameter becomes enabled. And the other thing that we do with validation is describe the output for chaining. So the way we do that with the script tools, we program something called a tool validator class. David will show in a Python toolbox, it's just all of that's together. There's a lot of power in Python toolbox, but the concept's the same. There's these validation routines. Gives you full control of the dialog and allows you to describe the outputs of your tool for chaining a model builder. I'm going to show this. I'm going to show you how a tool validator works, but what happens is that on the Properties tab of a script tool, there's a tab called Validation. And within validation, there's this idea that you initialize your parameters, and that gets called when the tool dialog first opens. Update parameters gets called every time something changes on the tool dialog, and you get to examine everything on that tool dialog. And then finally, after update parameters is finished executing, it goes and does that internal validation routine I talked about. And then it calls update messages, and you can do custom messages. So let me show you a little demo here of what we got going on. I've got a little tool here I've built. And the scenario behind this tool is that, well, you're a shop and you have this strange format for geographic features that's a table that describes has a coordinates and some fields in it. And whatever, this is kind of a very made-up example, but let me just show you some things you can do. We're going to choose a table to import, and the tool wants a primary field, whatever that means. I'm going to give it left from address. Now it wants a secondary field, whatever that means. I'm going to choose left from address, and notice I get this red X that says secondary field cannot equal primary field. That's something I programmed in. That's an error message I put in specifically for this. So I've got to choose before I can hit OK. It says, no, you can't execute. Good user experience. You can't execute until you give me valid inputs, and now I could execute. We have a format type. Remember, this is some like, again, a scenario is that you've got some special format of stuff at your shop, and you have a new format which supports polygons, lines, points, annotation, dimensions. And you have the old format, which only supports points, lines, and polygons. So notice here when I choose new format, this list expands. I can choose annotation. If I choose old format doesn't support annotation. It only supports these three things, point. Notice I got this, what we call a window shade here, these categories. If it's a point, I can choose further whether it's a multi-point. I can go to line here, and I can do a generalized or detailed line if I choose line. If I choose polygon, both these things are disabled. So that's just to give you a little idea of the things you can do with a validator to help the user. And I want to show you that validator. We go to the properties of this tool. It's general. Here's the source. Here's the parameters. Here's the validation tab. Now, if you want to edit this code, you can't edit it here. I'm doing the Stephen Colbert thing, where it does that. Nothing happens, right? What you have to do is press this edit button. And what it will do is open up that code within the Python IDE you've specified. And I should back up just a second. You specify that IDE under Geoprocessing menu, Geoprocessing options, Script Tool Editor Debugger. I've got PyScripter set up, so that's why it came up in PyScripter. So let me go back to this. I may have actually messed up here. Okay, there it is. I may have two copies of it. This is a tool validator. Class tool validator, define initialize parameters. That's a class method. Update parameters is another method. And then update messages is another method. So all I want to show here is an update parameters, initialize parameters I'm setting parameter dependencies. That's the fields. Remember in the UI, in the script tool wizard, I said obtain those fields from the first input parameter. Well, actually, when I write a tool validator, I'm taking full control of that and saying, I don't care what the UI, what you put in the script tool wizard. This is the obtain from. This is dependencies. You're going to get those fields from the first parameter. I'm going to stuff parameter 5 and 6, which is actually parameter 6 and 7, but it's zero based, into a category called more options. I could actually change this, yet more options. We'll do that. I got these two formats. I set those up. I got the old format, new format. And down here, I've got, this is an update parameters. Every time something happens, if they say old format, I'm going to put in point, line, and polygon. If they have new format, what the heck, let's change it and add something called Dev Summit 12. So I'm just going to alter that list. And down here, we've got to enable, disable some parameters, setting the enabled state. If this thing is point, then we're going to enable parameter 5. I've actually got something here called Dev Summit 12. You may have seen that flash by. I'll delete it. And I don't want to get too much into the actual code here. It's not really that important. You can read about it, all these methods, but they're all live and sitting here in this tool validator class. I'm enabling, disabling. Everything I did is governed by this tool validator class. And finally, in update messages, I check to see if parameter 1 and parameter 2, those are those primary, secondary fields. If their names are the same, throw up this error message. Secondary field cannot equal primary field. I'm going to press the Control S to save this. I go back here, and now I hit the Apply button. And what it does is, since I had it hit Edit, it's going to apply and bring that in and let you see it. And I think we'll see Dev Summit somewhere here. Did it apply? Dave, you see it? I don't know. We'll just run it. I forgot where I put it. Single point. Okay, well, I'm just going to hit OK. Hopefully it happened.
We'll find it.
Yeah, so see, I set two categories. I got yet more options, more options. New format equals that. These are, I get Dev Summit 12 as a format option, but if I choose line, I get this. If I choose point, I get that. Same thing here. If input table, I choose CFCC. I choose it here. I get that custom error message. And there it is. And I go there. And then actually all this tool does, nobody really cares because we're not talking about the executable today. We're talking about how you control the user interface. This tool, all it does is just list out the parameters and then gives you a little warning message that hard, nothing happened. Okay, so back to the slides. So what I've shown here is how you control the UI using the tool validator class. I set up keyword list, old format, new format, what type of point, line, polygon, did dynamic update of those key lists, things like that. Now something else that a tool validator does, and this is really a very important aspect of a tool, is that it needs to describe its output. Now what do I mean by that? I can show you very quickly. If you ever use ModelBuilder, let's just go ahead and do that. Let's just use ModelBuilder here. I've got a script. Excuse me. Let's edit this. I don't know, this is a very typical model. I've got the add field tool. Within add field, I'm going to add a field called Dev Summit 12. Field type long, hit OK. Tool has not executed at all, right? I'm in ModelBuilder. I'm just setting up my parameters. I'm setting up a chain. Now, I'm going to just, I've hooked up the calculate field here. Calculate field can't even run. I haven't even given an expression yet. But if I pull down this list of field names, Dev Summit 12 is there. Right? I didn't have to run the tool to add the field in order for a calculate field to see it. I'm in ModelBuilder, and it knows that, hey, this something upstream has added this, upstream being up the chain here, has added this field. Well, just demo it again, and here we go with X, Y, Z, Z, Y. Hit OK. Go to calculate field, open it up, and there's that field, X, Y, Z, Z, Y. So that's what I call describing the output. We actually describe what the tool is going to do before it executes. And that's what makes ModelBuilder so powerful as a visual programming language. You don't have to run things upstream in order to get downstream lists to populate. We know what's in there. So it's very important that the other thing about So the other thing about a tool validator is that you can describe the output before the tool exists. And if you're a script tool developer, you definitely want to do that because your users, which may be analysts, are using nothing but ModelBuilder. They don't want to do scripting. In order for your tool to work and work well, a ModelBuilder describes the output. Here's another example of describing the output. I'm using the clip tool. And the clip tool takes a clip data set and clips it out. Well, one of the things that we want to do when we describe the output, well, we got a new feature class coming out, but it's going to have the fields of the input, not the clip. It's going to have the fields from the buildings data set. Its extent, though, is going to be the intersection of buildings and study area, right? So I may be cookie cutting buildings, or over here I'm going to cookie cut, study area on top of it. Just that little piece is the extent. And it's important I do that because the next thing I'm going to do is go to the polygon and raster tool, and polygon to raster is going to calculate a default cell size based on the extent. So we want all that stuff to work well. So that's describing the output. So the way we describe the output in Tool Validator is that, and I'm not going to get into this, but David will talk a little bit about it. When you're in a Tool Validator, any output parameter has something called a schema object. And that schema object is you get it off of the output parameter, and you can set up rules. You don't say, oh, I want the schema, I want the output to be named this, I want it to be a point feature class, I want to have these fields. You don't give us specific instructions. What you do is you set up some rules. You say, hey, use the extent of the second input data set, or intersect the extent of the first dependency and the second data set. You may set up a rule like, use the fields of the input, but add these additional fields. I think I have a list of those. Let me just go ahead and show that list. Just to describe it a little bit more, and I'll hand off to David. So here's some of the things you can do with that schema object. You can, hey, the feature type that's of the output, I'm going to tell you what it is, or no, just take it from the first parameter. First dependency. What is this feature type? Hey, what geometry? What kind of geometry do you want? Point, line, polygon. You actually set it. The extent, the fields, all that stuff is set up by rules. I think David will show that a little bit in his slides. So that's it for kind of the script tool end of it. And David's going to show how it's done in a Python toolbox and why you would want to, some other reasons why, differences between a Python toolbox and a script tool and a custom toolbox.
Now, part of the reason I had Dale go through all the script tool wizard is conceptually really the Python toolbox and script tool wizard are, they're pretty much the same thing. It's just kind of, you create them in a different way, but things like parameters and validation, all of those things are really equivalent. And a lot of the code, actually, even that Dale had, like in the tool validator class, can be taken and adapted just slightly to work in a Python toolbox. So the key, though, for Python toolbox is everything is done in Python. So when Dale was going through the script tool wizard, right, he went through a wizard to define high-level information about the tool and the parameters. So in a Python toolbox, that's done in Python. He had the validator class that was in, he had to go through a couple button clicks to get there. That's included in the same file as is the execution source code. And one of the points we want to have with the Python toolbox is that just like the script tool wizard, any tool that you create, will look and behave just like any other tool. The idea is that, just a little bit of work, you can create, fully functional geoprocessing tools. Now, in a Python toolbox, we do that by defining classes. So every Python toolbox will have one toolbox class. That's sort of how ArcGIS recognizes Python toolbox as what it is. And then it has one or more tool classes with methods that define the tool, establish your parameters, a series of validation methods, and an execute. So we'll come back to this in a second to see it more clearly, but this is sort of the default toolbox class. So every toolbox will have one of these when you create it in the beginning. And then you'll have one or more of these, the tool class, with a series of parameter and validation and execute methods to fully define the tool. So in ArcGIS at 10.1, you can create a Python toolbox with right-clicking in any folder, creating a new Python Toolbox. To look at it, all you have to ever do is click Edit. That'll bring it up in an IDE. So there again, here's the Toolbox class already created for you, and then one tool class stubbed out. So we define the parameters in here. We have a series of validation methods. The update messages and update parameters are direct equivalents to what Dale had, or what Dale showed in the tool validator class. With Python Toolboxes, we also now have an additional isLicense method to help you assess whether or not the tool is valid to run based on extensions or other criteria. And then at the bottom, to execute. So to make changes and have them reflect, I already had copy and pasted a parameter definition. So here I'm just defining a parameter using an ArcPy parameter object class, setting a few properties on it. If I want to see this inside the tool, I just return a list of parameter objects. And if I come back in the application, refresh, I'll have that parameter generated. So, as you make changes in a Python toolbox, it's just a matter of going back into the application and refreshing it, and it will come right in. Because Python, we don't have to compile. There's not all this sort of substep of making it come in. It's really just there's the file, refresh it, and whatever's in that file will get read as a toolbox and tool. Now, a couple months ago, I got an email, something like this. And I get emails like this fairly often. Someone has a fairly simple problem that can be achieved by really not a lot of Python code, and they're just looking for an opportunity to hook it up into a geoprocessing tool. So in this case, there's an internal person, they were working off-site, and they were trying to automate with this customer an existing manual process. So he had a series of polyline features. He wanted to be able to generate points at a fixed interval along those lines. He wanted to know if it could be done through either geoprocessing or Python. Well, it can be done through both. There's no existing geoprocessing tool that can do that. That's sort of the nature of geoprocessing, right? It's a combination of tools to support some workflow. And sometimes you'll get into cases where, there's little pieces of that where there's no existing tool for that. So that's sort of an objective of script tools and model tools too, and Python Toolbox is to kind of fill in those holes. So that's what this tool here is. So the amount of code to create this was actually not all that much. I won't get into the full nature of this, but basically we're creating a feature class. We're adding a field on here. This is just, instead of pulling all the fields over from my input, I'm just adding sort of a dummy field with the FID from my existing input. So I can join fields back to my output if I want later. And then with a combination of cursors and a new geometry method, I'm creating new points based on those lines that are coming in at a fixed interval. The rest of it is really just sort of the window dressing, right? That's kind of the point of a Python toolbox. You want to take that functional bit of code and turn it into a tool, fairly quickly and easily. The nice thing about what Dale was doing is you're walking through the wizard and you can kind of see all those decisions you make, and that demos very well. But when you get back to your office and you have to create, 10 tools, 20 tools, or you're walking through a lot of different things, those little decisions running through a wizard start, adding up, right? You make a parameter change, and it ripples down here. You got to make some additional change in a validator code. All that kind of bouncing around can be, difficult when you have a lot to do. Python Toolbox, you can do all that in one place. So, in a GetParameter info, it's where I define my parameters. So, the way I want this tool to look, based on what I've been describing, is I wanted to take, have an input, a first parameter that takes input lines, a second parameter that's an output and creates points, and then I want to supply a third parameter, which is a distance or some kind of interval. So every parameter is defined by a parameter object, and there's a series of properties that you can find on a parameter. But there's really only 5 that you really need to do each and every time. So there's the display name. That's what you would see on the tool dialog, basically the label of the parameter. The name is what you would see in Python if you called this tool from Python. The data type, which is key. Dale sort of had an exercise there where he was working with a table view. Feature and feature class, feature layer have sort of the same kind of relationship. If you want to be working with your tool in map and be able to pick layers or feature classes, you need to pick a feature layer, not a feature class. Same kind of ideas with table view and tables. And you set your parameter type, the required, optional, derived, and then direction, the input or output. And then I've also just set it, Dale was able to filter some of his parameters. I'm doing sort of the same thing here. To that parameter, I'm applying a filter list so that it only picks polyline geometries. And then similarly, I have an output parameter and then an interval. And then at the end, I just pass those back as a list of parameter objects. I'm not using any of these right now. These are all optional. In this next exercise, we'll walk through those a little bit more. And then in execute, being the last one, this is what happens when you execute the tool. So the key ones in execute, you have an incoming parameter object and a messages object. So parameters are accessed by an index. It's like a list of parameters. Same parameters basically you defined earlier. You can get them either in a Python toolbox as value as text if you want the string equivalent of that parameter, or like the interval, that's just a number. So instead of taking the number as a string and then putting it back to a number, I'm going to use value, pulling it as a numeric type. If I wanted to add messages in here, you just basically do a messages, and then there's a number of optional methods on a messages object that can provide warning messages, error messages, informative messages. So if I close that, this is the earlier one. And if I run this, it'll just be just like any other geoprocessing tool you would normally expect to see. So I can grab my rivers feature layer. So we'll auto-populate an output, and then I can set a fixed distance. That tool will take a few seconds to run, and will generate a polyline feature class, or a point feature class. Right, there you go. The another thing about Python Toolbox is, occasionally you're going to go through this and you'll be making mistakes. Wrong one. What happens if you make, mistakes? So for instance, in my GetParameter info, let's just say that, I'm referencing something that doesn't exist. Oops. Okay. Come back up here, refresh it. All right, okay, so now there's an error. Tool won't run. If I click on it, it really just clicks off. It doesn't know what to do. But there is an X on here.
Oh, okay, yeah.
Yeah.
Can you see that? The tool actually has a...
Yeah, the icon's fairly small, but there's a little red X. Double-clicking the tool does nothing. But there is just one option here, Y, right? And this will generate basically whatever the traceback is for that exception. So it'll come right up. For instance, here it's telling me there's just sort of some kind of name error on line 46. So I can go back. Oops, I've got multiple versions of this open. So let's go back.
Yeah, PyScripter seems to want to tell you 1,000,000 times that you have it open.
Yeah. So here we are, line 46. You can resolve your error. Save. Yeah, I think, I deleted the other Python toolbox I had in the application is gone, but I didn't actually close it. It's trying to auto-save it. Anyhow, you can go back, refresh, and the problem is solved. All right, so this walks through the major components that we were looking at there. So parameters you define inside that GetParameter info. You can define as many parameters as you want. There's just those 5 key characteristics you have to define, and then there's a series of other ones that are optional to fine-tune or specialize the parameter even more. When a tool is executed, parameter values basically come out of GetParameter info with the values and go into execute. With parameters, probably the key part of the parameter is the actual data type. So in the last one, I was working with feature layer on my input. That's sort of how the tool recognizes and works with the data, right? It's a core concept of geoprocessing. Every tool, every parameter has a series of data types. And while there's actually quite a few data types, like if you went and go through the full list, I think there's well over 100. But really, it breaks down to, most tools are a collection of about, 6 or 7 different data types. Things like strings and doubles, booleans, feature layers, table views, raster data sets. And what a data type provides for you is sort of it's a recognizable little thing. It has, its own built-in logic. It has a, familiar UI control. And then when you receive that inside your code, it has a string representation that you can use. Now, when you're working with tools and parameters, every tool that has an output data set is...
Excuse me, every tool... Oh, well, hold it.
Well...
Yeah. Every tool always has an output. You must have an output.
Yeah.
If you don't have an output, you can't use it in ModelBuilder because people can't chain. Mm-hmm. So I'm sorry, I had to.
That's a good point. And ones that are output data sets are particularly important, right? If it's just something like a number coming through, right? The number is the number, right? It's it's a small entity. You know exactly what that is. Something like it's a feature class or raster data set or something. There's a lot of characteristics to that may impact what's going to happen if you're using a tool in a model builder, and several tools follow. So for instance, if you look at this code sample here, sort of assuming some parameters have been defined up ahead, but I'm going to take a case where we have an input, say, feature class and an output feature class. And the output feature class is going to be entirely based on what the previous one was. But we're just going to do one thing, and we're going to, say, add a field. So I can set the parameter dependency back to the first parameter and then clone it to be true. That'll bring forward everything. But then any additional changes, there's a lot of, Dale just showed, well, you showed them all, right?
Yeah.
Yeah, there's a long list of things you can fine-tune it with. In this case, I'm just taking a field, and I'm creating a field object, setting a few properties, and then defining that on the schema as an additional field. So inside the next tool, like in Dale's kind of add field, calculate field case, the second tool will see that field even though it has not yet been created on the input. So when we talk about validation, validation is everything that happens before you hit that OK button, right? It's all about customizing how parameters interact with each other, right? And respond to the values that the other ones have. Basically a way of fine controlling tool behavior. And in Python Toolbox, we have, two specific ones to work with parameters. The first one is update parameters. And again, this is equivalent almost exactly to what Dale had with the script tool wizard. Allows parameter interaction. You can calculate default values. You can turn parameters on and off. It's essentially called anytime a parameter value is altered. So in this specific case, if this was in update parameters, I'm assuming that there's actually a number of parameters. You can see the range 0 and 6. So the first parameter has a value, and I haven't already, I should back up. So we have a tool that has like a feature class, right? And there's a parameter further down that has some kind of threshold based on extent, all right? So you could, if you were using this tool, you could manually change that threshold, or you could have the tool auto-populate it, right? So if the first parameter has that feature class in it, and the second parameter has not been manually altered by someone typing it in, then we're going to try and figure it out. So I'm getting an extent by describing the first parameter up here, and then based on whether the extent width is greater than the height or not, I'll do a different calculation and then send that value into the parameter. The other main validation method is update messages, and this is called after returning from internal validation, and it provides kind of a means to provide your own error and warning messages and modify ones that might be coming through. So in this case, I have a little check basically to say, okay, well, if my input is GDBase feature class and it's versioned, it's not versioned, I want to put a message up. That's important for some workflows, right? So I'm going to make a judgment right away that if it's not versioned, I'm going to throw an error using the set error message back to the tool dialog. And the last validation method we have is something that we didn't have an equivalent for prior to 10.1, and this is an is-license check. So historically, you can be running a script that has a number of tools in it, right? So imagine a situation where you're using a tool. Inside your tool, you have several tools, and say way down at the bottom, there's a 3D analyst tool. Well, you can let a couple things happen. You can put like a specific check into your script, and oh well, I don't have that. Well then, raise a warning or error, fail somehow, or I could just let it go and go through 90% of the code before failing because the tool is not authorized. Well, is-license sort of brings that up to the front. So instead of being able to double-click on a tool that you won't be able to run, if you set your is-license method to return false, it just won't work. You'll see a little blocked icon, so you won't be able to use the tool. And then execute it is the last part. So the business logic, your algorithms, the workflow you want to achieve, that's what's found in execute. And as I mentioned earlier, execute has a few arguments for dealing with both parameter and messages. So this is another case I had. So this goes a little bit further back, but a year ago, I had some guys that came to me internally, and they were looking sort of for a way to identify features that were really, really bendy, had like a very high sinuosity. So sinuosity is really a measure of how a line bends. Their concern was that lines that were very bendy were going to present some trouble with labeling, and they wanted to flag those ahead of time. So what you need to be able to do something like that is actually fairly simple. The amount of code is really just a few lines. And pull it up. The functional code to do that is, oops, sorry. There we go. Okay. All it really needs to do is I'm, adding a field based on this expression. I'm going to do a calculation. So of course, calculate field has the ability to take Python code blocks. So if you haven't seen anything with syntax before, I basically got this is like a multi-line variable. So I'm assigning this huge block of code to this expression, which I'm passing down the calculate field. Okay. But that's not the main point. The main point is actually that, this is a relatively small amount of code that should be able to just plug into functional Python toolbox and run quickly. So it says all sort of the same parts as my previous example. The one key part, though, of course, is that, let me back up. So the way this tool should work, will work, is it'll take an input, because this is sinuosity, I want it to be on a line feature, so this will take only polyline features, and then I'm going to add a field of my choosing. I'm going to supply default, but the user could come in and modify this, and then just run it. Now, if we go back to the script, and to kind of play off what Dale was talking earlier about schema, this, on that input, on that tool dialog, right, there was only 2 parameters, but I'm actually, I'm modifying my input feature class, so I need to create a derived feature class, or a derived parameter. And that's what this does.
Yeah, so it's just like the add field tool. When you drop add field in the model builder, you get an output, right? And that's all that Dave's setting up here. All he's going to do is modify the input feature class. But for model builder, he's got to have that output because you got to be able to chain. Because somebody's going to want to do something like select all those sinuous things and select layer by attribute and do something else. Well, you have to have an output.
Yeah. I thought I had another part of this. So another key consideration, though, for that second parameter, my sinuosity field value, is that it could be typed in, right? And it could be typed in incorrectly. Someone could type in a field name that is not kosher for whatever their feature classes they're adding it to. So in my update parameters method, I can do a quick little check to see if it is. So all I'm doing here is to check, well, one, that the first parameter has been altered, so that I have something there, I can count on it. And I do have a parameter value specified. I'm going to feed that into the ArcPy validate field name, and whatever that gets updated as, I'm going to update my tool parameter with that value. So if I took this out and came back up here and refresh, I could type in really anything I want, regardless of whether or not that would actually work, right? It's just going to stick there. And it would, if I tried to run that tool, it would go in and it would obviously fail at some later point. I want to influence how that works. Just uncomment this. Come back and refresh. So now if I type in something that's, obviously ridiculous, it's going to, validate that. So the field name on the tool dialog is now acceptable. So when it gets pushed into the tool, I can expect that the code will run expected. So let's just run this as we would normally. So let's pick the rivers, set my sinuosity field. It's running in the background. 1 second. If you're ever waiting for something, you can just go into results and
that's the first time you ran it in background, so now it's running the background process.
Yeah.
How many people run tools in background? How many people run tools in foreground?
Yeah.
Okay, so there's some people that don't run tools at all, I guess. But okay, so the idea with background is eventually, we're going to be leveraging background more and more. So we are using other CPUs. We're using some new technology, and it has to do with server and stuff, and how it's basically going to be kind of the same thing as a server running on your machine. But when you first run a tool in background, it actually has to spawn up the background process, and that's what just happened to Dave. Mm-hmm. And but once it spawns up, it'll just run right through.
All right, now because it's a tool that just modifies my input, there's no obvious change to what just happened there. So let's just validate that what I did actually did something. So if we zoom in a little closer, actually, all right, so I select two features here. And you can see there's one kind of long feature, right? This bends back on itself. It's really ripples back and forth quite a bit. And then there's one shorter line that's fairly straight. I look at the table. Right, the short straight feature has a very high sinuosity, about 0.9. The lower one, the much more curvier one, has a sinuosity of about 0.36. So that's all about just sort of creating, a simple, taking a little bit of functional code, wrapping it inside a toolbox and making a tool out of it. Now, I just want to mention this kind of as a word of note, of course. So, a Python toolbox can create, you can include as many tools in that toolbox as you want, right? I'm just doing two simple examples, so they both had one, but, there's no reason why you couldn't have, 20, 30, hundreds, right? At some point, it doesn't necessarily make sense to start combining all of that code into one file, right? So just as a word of note, you can organize your files out, right? So you could create the functional code and write those as separate Python files, and then import those into the main file. And that's all that this is doing. So in a simple case, I have a utilities file I've created, and then I just have a little method off of that I can call and send parameters into that. Now there's a few little bonuses that the Python Toolbox have that we didn't have any access to with the Geoprocessing script tool. I'm just going to walk through some quick cases of those. So we support three new things, really. Composite data types, that's where you combine different parameter data types together. So you think about a tool like the buffer tool, right? It takes a buffer distance, but it also allows you to do the buffering based on a field on the input. You had no way of really expressing that previously. The second thing is value table. So we have a number of tools in the software right now that have a value table type parameter. That is, we're sort of a table, and you can sort of select multiple things into that. So some of the overlay tools allow you to pick multiple feature class or feature layers, but then also add a rank to help assess how those features will be cracked and clustered. And then the last one, which I mentioned briefly earlier, was custom license checking. So this little toolbox here just has three sort of samples. I bring that into... So the first one we'll mention is talk about composite data types. So if you want to specify composite data type, it's a parameter object just like any other, but instead of specifying, a data type equals some string, it's now really just a list of strings. Right? So in this case, I'm going to represent it sort of like like the buffer tool. So you have a linear unit, you can specify some sort of a distance or a field, based off of the input. If I double click on that, I have an input feature class, an output feature class, and then this distance parameter. So if I added a feature class, could either type in, a distance here, or I could pick a field from my input. The second part is a value table. Value tables are just another type of parameter. The difference here is that you set the data type to be a value table, and then the columns in the tables are defined with a columns property, and you can assign it either a list of parameter objects with a few properties defined, or you can do a set of lists with the data type for each column and then the heading that you want that column to have. If you go back to that, that'll provide something like this. So I can put feature classes in here. I can assign them ranks. It has the same controls that you would have on a regular value table parameter. Move things up and down. You can delete things, add things. And then the last thing is a licensing check. So, certain times you just don't want that tool to ever be run because, what's the point, right? You just don't have the extensions or whatever criteria you need on that machine to run. So in that case, just using the isLicense method like we saw on that slide. And in here I'm evaluating extensions, right? 3D Analyst extension. But you could add any criteria you want in here, and anything you need to be on your machine or running on that machine to work, and you can return a true or false. Yeah. So I had it false by default actually. So if I set it to true, come back in here and refresh. Well, now that little special icon is gone, and I could double click and run the tool. So there's just a couple sort of caveats to this whole experience that I want to make sure that we're all familiar with. Is that when you have a normal toolbox file, like a TB file with a TBX extension, you can add model tools, you can add script tools, you can copy a system tool into that toolbox. Python toolbox is not organized in the same way. Anything in that toolbox has to be defined inside the code, and you can't define a model tool through Python, right? And the other thing is, at 10.0, maybe not everyone will be familiar with this or aware of this, but you could embed a Python script inside of a script tool. There was an option. Once you've added a source code, you could embed it, and then you could also encrypt it if you want. That's also not supported with Python toolboxes. All right, well, that's all I had.